Hello, today we're going to look at simplifying expressions that involve rational exponents, and all that means is we are going to have some expressions that have exponents in them, but those exponents will either be all fractions or some of them will be fractions. Your same exponent rules apply, it just happens to be that your exponents are fractions. We're going to be focusing on three main exponent rules today. The product rule, which I have here in blue. When we multiply two things with the same base, we add the exponents. The quotient rule, when we divide two things with the same base, we subtract the exponents. And the power of a power rule, which is when you have inside exponents and exponents outside of parentheses, you multiply or distribute those exponents together. We've seen all these things before, but now we're just looking at them when we have fractions for exponents. And it does most pulled off to the side here. If it's been a while since you've added or subtracted or multiplied fractions by hand, using Desmos can be very helpful. I highly encourage it because I'm not as concerned with can you deal with fractions by hand as I am with can you simplify these exponent expressions that have fractions in them. So I'll be showing you how to do a fraction things in Desmos. If you're more comfortable doing them by hand, by all means go for it. Just make sure you get the right answer. So let's take a look at this first one. I'm going to be using my product rule because see multiplication here. And just like when we've done product rule in the past, we know we're going to multiply our coefficients. But since I only have one coefficient, in my final answer, I'm going to have a coefficient 3 no matter what. And then I'm going to add any like exponents. So for x's, I have a 1/2 and a 1. So I'm thinking x to the 1/2 plus 1. For y's, I have a 2 and a 3/2. So I'm thinking y to the 2 plus 3/2. What I have written here is kind of an in-between step. This is not your final answer. We need to actually do this addition. I just wanted to show you where things are coming from. So to get our final answer, like I said, coefficient 3 is going to stay the same. If you want to add these fractions in Desmos, go for it. Remember that to do a fraction in Desmos, you use your division key. So 1/2 is 1 divided by 2. And then arrow over to get out of the denominator plus 1. And then Desmos gives you a decimal. We don't want it as a decimal, we want it as a fraction. So if you click over here where you see box over box, that will turn it into a fraction for you. So we get x to the 3/2. And then same idea with our y. I'm going to add our exponents, 2 plus 3 divided by 2. We don't want a decimal, we want a fraction. So click here. And that tells us that the y exponent is going to be 7/2. You know you're finished when you have a coefficient and you see each variable only once, and that the exponents you see on those variables are either an improper fraction like we have here or an integer. We don't want decimals, we don't want mixed numbers. Let's try another one. Number 2 is the same idea. Coefficient 2 is the only coefficient I have, so no matter what, in my final answer, I'm going to put 2 coefficient. For a's, I have a 1/2 and another 1/2. So 1/2 plus 1/2. For b's, I have a 1/2 and a 5/3. Let's use Desmos for those fractions again. Like I said, coefficient 2 is going to stay the same. A, you probably know them off the top of your head, but just to get practice using Desmos, 1/2 plus 1 divided by 2 is 1. Remember when we have a 1 exponent, we can write it, but we don't have to, so I can write a to the 1 or just a, they mean the same thing. And then for b, 1 divided by 2 plus 5 divided by 3. And we don't want that decimal, turn it into a fraction. We get 13/6. If you, when you're doing these on your own, if you do your exponents in different orders, so like for instance, if you did 2b to the 13/6 and then a, that is perfectly fine. We do want the coefficient in front, but the order of the variables is not very important. All right, next up, 3 and 4, we're going to be using that quotient rule, which is the rule I have here in red, which says that when we are dividing, we subtract top exponent minus bottom exponent. We'll also divide or reduce coefficients if we can. For number 3, 3/2 doesn't reduce, so no matter what, we're going to have 3 on top, 2 on the bottom. For m's, make sure you're looking at m's carefully. I have a 3/2 on the top, and then minus my bottom exponent, which is a hidden 1, so I'm thinking 3/2 minus 1. For n, and it helps if I actually write the letter n, top exponent is 3/2, Bottom exponent is 4 over 3. So I'm going to finish this off. I'm going to actually do my subtraction, same idea. 3 divided by 2 minus 1 gives me 0.5, which is the same as 1/2. So I get m to the 1/2. And then for my n exponent, let's turn that into a fraction, get 1 over 6. And there we have it. A lot of times with m's and n's, people mix things up. Make sure you're looking very carefully at which exponent goes with what. Number 4, look at our coefficients. Can I reduce 4 over 2? I definitely can. 4 over 2, or 4 divided by 2, is just 2. So I'm going to get 2 as my coefficient. I only have one x in this whole problem, so it is going to say just regular x. And then for y's, I need to do top exponent minus bottom exponent. 3 over 2 minus 5 over 4. I'm going to do that here in Desmos and turn that into a fraction. So my final answer will be, like I said, 2 stays the same, x stays the same. For y's, when we subtract, we get 1 over 4. When you're doing this on your own, you do not have to write this in between step here like I've been doing. You can just jump to the right with the final answer if you would like. Alrighty, 5 and 6 are going to use that third rule, the power of a power rule, the one I have written here in green. And what your power of a power rule says is that, let me go back to it there. When we have inside exponents and outside exponents, we multiply them together. It's like you're distributing the exponent. So here we go. I'm thinking u to the 3 over 4 times 2, and I'm thinking v to the 5 over 4 times 2. I'm going to do these things in Desmos. 3 divided by 4 times 2. Turn that into a fraction. I end up with u to the 3 over 2. And then let's do the same thing for our v. Turn it into a fraction, and we get 5 over 2. And that finishes that one out. And another thing, friendly reminder in Desmos, this is getting pretty cluttered. If you want to get rid of everything you've typed in so far, if you hit this little green, or this little gear looking thing and hit delete all, it'll clear everything out. So sometimes it's helpful when you're doing a lot of small calculations. Let's try number 6. So we know we need to distribute this. I'm thinking m to the 2 times 7 over 4. I'm thinking n to the 5 over 4 times 7 over 4. Let's use Desmos to do our multiplying. We're going to turn things into fractions. For our final answer, we get m to the 7 over 2. And then for n, we get 35 over 16. So you might end up with some unusual looking fractions like 35 over 16. That is perfectly fine. Once you start dealing with power of a power, you can get some larger numbers in your fractions. Not a problem whatsoever. The rest of the problems we'll be looking at today will combine product rule, quotient rule, power rule in some capacity. Just kind of as a general rule of thumb before we look at problems, if you have some product rule to take care of someplace, like in 7 and 8, you have product rule happening in the numerator, do that first. And then for the rest of them, see how we have some power things with parentheses here. Just like other things with math, if you have parentheses, you usually do that first. I would recommend that for those. You can do a lot of these more than one way. So if you take a slightly different path but get the same final answer, you are good to go. I'm not going to show as many in-between steps as I did here, just because things will get cluttered. So for number 7, let's start in the top part of that fraction. Looking at the top part, I have a coefficient 2. It's the only one I have. For x's, I need to add those x exponents together. So 4 over 3 plus 2 over 3 is 2. And then for y's, I have a hidden 1 and a 5 over 4. So 1 plus 5 over 4 is 9 over 4. I have not done anything to the denominator yet, so I'm going to leave that the same. So now what I have in orange looks like what we did back with our quotient rule. We're going to divide coefficients, subtract exponents. 2 over 4, if I reduce that, is the same as 1 over 2. You could write that coefficient 1 on top, but you don't have to, so you can do 1 on top, 2 on bottom, or just a 2 on bottom, either way. Now I'm going to subtract top exponent minus bottom exponent for my variables. So for x, 2 minus 3 over 2 is 1/2. So x to the 1/2 goes on the top of the fraction. Same idea with y's. 9 over 4 minus 1 over 2 gives me 7 over 4. I only see a coefficient, and it's reduced, and one of each variable, so I'm done. Next up, let's once again start in the top part of the fraction. Coefficient-wise, 2 times 2 is 4. I only have one u exponent in the whole top of the fraction, so that's going to stay u to the 3 over 2. For v's, I have a 1 and a 1/4. So 1 plus 1 over 4 gives me 5 over 4. Denominator I have not touched at all, so I'm just going to kind of write that all down so I have it. Make sure you have everything there. I almost left something out. Now let's use our quotient rule. For my coefficients, 4 divided by 2 is 2. For u's, top exponent minus bottom exponent, 3 over 2 minus 1 gives me 1/2. So I get 2u to the 1/2. For v's, top exponent minus bottom exponent, 5 over 4 minus 1 over 2 gives me 3 over 4. And that right there is my final answer for that problem. 9 and 10, like many other things in math, if we have parentheses, we're going to start there. So we're going to start by using our power rule here. So I'm going to get rid of all these just so we can see things better. So for a, 4 over 3 times 2, 8 over 3. For b, 1/4 times 2 is 1/2. And then I haven't messed with this other part here, so I'm just going to bring that along and not change anything with it yet. Now I go back to product rule. I need to add my like exponents. So for a's, I'm going to do 8 over 3 plus 2 over 3, which is 10 over 3. And then for b's, I have 1/2 and 2/3, which is 7 over 6. I only see 1a, 1b. My exponents are all simplified, so I'm all done. Same idea for number 10. This becomes u to the 3 over 2. And then for v, doing 5 over 3 times 3 over 2, which is 5 over 2. Something else we can go ahead and do here is we can simplify this part by adding exponents. So if I'm looking at just the part I have kind of squiggled under for u's, I have a u to the 4 and a u to the 7 over 4. And there, 23 over 4. And then same idea for v's. I have 7 over 4 and I have 2. So I'm going to add those together, which is 15 over 4. So then to finish this all out, these are all getting multiplied together. So I'm going to add my exponents using my product rule. So for u's, 3 over 2 plus 23 over 4